Hello friends, welcome to my channel. Let's have a look at a newly appeared problem, problem 2434, using the robot to print lexicographically smallest string. In this video, we're going to share a solution based on the use of stack and counter. Here the counter is a subclass of the dictionary abstract data type in Python. So here, actually, the goal is to return the lexicographically smallest string that can be written on the paper according to the two requirements item, so specified by the problem. So here, what we can do is to remove the first character of a string from the string s and give it to the robot, and the robot will append this character to the string t. So the second one is that remove the last character of a string t and give it to the robot, and the robot will write this character on paper, right? So here are some examples, but however, these examples are not generic enough. But in example 1, so the return is AZZ for sure, and in the second one, the return is ABC, right? In the third one, the return is ADDB. So the constraint is that the length of the string is bounded above by 10 to the power 5. And the second one actually is an important one for the implementation in this problem. So here S consists of only English lowercase letters. So English lowercase letters in total are 26, right? Is a bounded size. So with that said, let's look at the method and some walkthrough. So first, the method involves the use of stack and counter. So once we build the intuition below, actually writing the solution is very simple. So the second item specifies the idea and written in detail. So the idea is that we linear scan the string s and we add character to a stack. So meanwhile, we check the mean character or lexically smallest character in the remaining part of S. So once we find that the top element in the stack is less than or equal to the mean character. So here less than or equal means it comes before the mean character in lexical order. So we shall pop and print. So we're going to continue the process. Then we're going to print out the lexical smallest string. So this is the overall idea. So the third item is meant to build the intuition. Actually, it's sufficient to demonstrate one pop operation to understand why. So let's look at this string. S is CCAZBA, right? So we scan S up to A. So because each time we look at the character, we add to the stack. So then up to this A, so with the rest is ZBA. So with mean character A, right? So in this case, our stack will be CCA, and we shall pop A to make this A the beginning of the result string, right? So this is why we can make it smallest in lexical order. So here we can imagine we cannot pop earlier. So for example, at C, right, we are going to get a larger lexical result. Or we cannot pop later, say at next Z, so we're going to get a very large lexical string. So both cases yielding lexical larger result string. So we just need to continue the above procedure, so to analyze the output. Actually, for this example, the output is AABZCC. So here is a walkthrough. So here I'm going to use very detailed analysis. So here we have S, so the return should be AABZCC. So here the process is like this. So when we look at this first character at index 0, so the character is C. So the remaining part is from here, the minimal character is A, right? C is larger than F1, so we just add to the stack, but we do not pop. So in this case, this is the stack state. So this is the mean character of the rest, and this is the print list state. So actually, we do not need to use a P in the coding, but we use this for clarity or for the ease of explanation. So next we look at the second character C. So in this case we add to stack, we have C, C, but the remaining part is A, Z, B, A. So the main character is still A. So we do not pop. So P keeps this empty state. So when we look at the second index 2, so third character, so we have A, right? So we add A to T, so we have C, C, A. But this remaining part has main character A. So in this case, as long as the top of the heap of the stack is smaller than or equal to the main character, we are going to use pop. So because here T-1 is less than or equal to the main character of the rest, we keep popping. So we get T equals CC, and we have P equals A, right? So this is one pop operation. So we are going to look at the next character Z, right? So we add Z to the stack T, and then the main character of the rest part is still A, but the state of P due to last step is A. Because Z is larger than A, so we do not do pop. And then we look at the next character at index 4, that is B. So we add B to the stack T. So because the main character is still A, right? So B is larger than A. So we remain P being a single element A. So next we look at the character at index 5, that is A. So we add it to the stack T. So we get C, C, Z, B, A. And the remaining part is null. So in this case, we are going to set the main character to be Z, the largest possible. And then we are going to pop as long as the top of the stack is less than or equal to the main character. So we keep popping from T and add to P. So we get, originally it's A, right? We get A, B, Z, C, C. And finally we just join all the characters in the list P. So we get the desired output. So this is actually a very detailed walkthrough. So here, this is the remark. So in implementation, we shall retrieve the main character in the remaining part of S. So this is actually simple. So we could use counter S, which is updated during with the scan of S. So you will see the detail. And finding main character or main key is simple because the second constraint. So the length of the counter of S is less than or equal to 26. So actually we can also do the check from A to Z in an increasing manner. So this is also a possible way. So actually I saw some solutions using this style of checking. So let's present these two formats of solutions. So first I'm going to write a solution using counter stack following the above idea. So first I'm going to initialize a counter. So this count is a counter. So actually it's in some detail it's collections counter, right? Counter class. So this counter class is a subclass of dictionary in Python. So next we're going to initialize a P, which is going to hold our characters, so in printing order. So this is actually not absolutely necessary, but solving a problem and it's different from explaining a problem. So this is the P, so we choose to do it to make it more clear. So T is the current stack. So now we are going to do a for loop for character in S. So what we are going to do is we are going to append this character to the stack, and then because we examined the first character, the rest actually have this character removed. So we are going to update the counter as we specified in the remark. So what we are going to do is actually count. So the count should be decremented by 1, right? So if the count character equals 0 after we decrement it by 1, then we're going to delete this key. So del count character. So in this next we're going to check the mean character in the current state of the count dictionary. So this is actually easy. The reason is due to the bounded nature of the case, right? It at most 26. So for this purpose, because we want to find the minimum, so let's make a larger one. largest initialization, that is z, right? So then we want to check if count keys. In other words, so the keys forms a non-empty iterable, right? In this case, we are going to update this to be min of count keys, right? So this is the set for the lowest character or min character in the rest of the string when we look at the current character. Then what we are going to do, basically, it's a while loop. So what we want to do is while t. So in other words, the stack is not empty. And under this condition, if the top element of this t is less than or equal to the low character, right? So we are going to pop from t and add that element to p. So in other words, p plus equals, or let's see, p append. So t pop. So this is the operation we are going to do. So once we finish this while loop, so we actually get the characters printed in order, so in P. So you can imagine this P is short for print or print array. So what we are going to do is to return the join of this characters in P. So with that done, this provides a format of solution to this problem. Let's first do a check. So character, so this is the count, CNT, right? Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes the generic case. How comes it's so slow? So with that done, so let's make a little bit change. So we can copy this function signature, and then we want to do the examination or update of low from A to Z in increasing order. So I'm going to call this one V1. So now what we are going to do is that, so first let's initialize these things. So now let's call this min character to be A at the very beginning. So this way we start from the lowest possible, right? Then what we are going to do is to do the for loop following similar logic. So what we are going to do is for character in S. So we are going to append this character to the stack, and then the count should be decremented by 1, right? So what we are going to do is to check, so what's the current lowest or min character. So this can be done using a while loop. So we check from the current low state and so check if this low is in the current state of counter. If not, we increase by 1 and then check if it's in. So that way we can get the lowest or min character in the rest of the string or in the current state of the count dictionary. So, right. So this is actually very simple. So while count low is 0, right? It means so here we didn't dial the key, right? So and low is less than z. So if low equals to z, so we cannot update anymore. So we are going to set low to be character. So we are going to increment this, so we can get the ordinality of the current low, and then increment it by 1, and then come back. For example, low is A, so we add 1 and then return the character that will be B, right? If we get B, so we add 1, so we get C. So this way, once we exit this while loop, either this is not 0, it means so this corresponds to the lowest min character, or we have something like this: low equals z, so like the initialization in the first version. So that's the largest possible. We do not do anything from there. And then what we are going to do is to use this while loop. So while t. So this is necessary for check the next condition, and t top is less than or equal to low. So here we should write less than or equal to. So this equality part is also important. So what we're going to do is p append t pop. So once this done, so we are going to return John p. So that's another format of solution, essentially the same solution. So for sure, we can make some optimizations. For example, we do not need to introduce this p even. But okay, let's keep the current format. Let's do a check. Yeah, it passes one example. Now let's look at this generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for the solution to this problem. So here for this video, actually, we use two ingredients in the solution. So one is the stack. The stack is used to try to get the minimal lexical print out. And the counter is to check the remainder part of the string for mean character. So with that said, I guess that's about it for this video. Thank you.